For the abstraction to work, we have to be able to give it data to work on. Meaning, yes, there are abstractions that don't deal with data. Like let's say, I don't know, print something and just print some sentences on the screen is the same sentence all the time. But if we want to get a mathematical version of this abstraction, which in a sense, in math, that's what functions are. They are an abstraction. If we have f of x is equal to some function, then f is abstracting away the details and we're just getting the value, right? So here too, if we want to somehow give it some meaningful way of functioning over different sets of data, so we have to be able to give it parameters. Now, parameters can be passed to the function directly or by giving it, like having work on globals, for example. Then you just change the global, the function will give you a different answer every time, right? Or we can go and give it a list of parameters, which just means that we are passing in values into the function and we're actually getting a different output. So we have direct access to data, and we have indirect access to data using parameter values. Now, the way we bind the parameters that we pass in to their representation within the function is what's known as binding, parameter binding, whatever it is. And it has actually real names. What I mean to say is the following. Inside the function, we have some variable which represents the value. We know those as arguments, right? So if we have, for example, we have a function that says the following. Suppose I have a function that looks like a piece of code that looks the following way. Let's not say the code. Let's say f of x is equal to x squared, and you can imagine what the equivalent code would look like. Now, x is representing a value. Notice x is not the value. X is just representing a value, right? So if we have, for example, f of 3, we will get 9. If we have f of 4, we will get 16, right? So in the first case, in the first instantiation, x got the value of 3. In the second instantiation, x got the value of 4. These guys right here, the x here, is known as a formal parameter. Right? It's something formal. It doesn't actually have a value. It's just representing some kind of value. And the number 3 down here is what's known as the real parameter. It's the real parameter. And what we have to actually do is bind real parameters to formal parameters. So in the current function, it's actually very simple, right? If we have a function that looks the following function, I don't know, pow, that gets a number, it gets a float, x, and what it does is return, I don't know, it's not pow, it's raised to the second, return x times x, right? And then we call pow, or just give it the number 3, and we get the 9, right? So x is our formal parameter, and this is our real parameter. And that's our real parameter. And we actually bind the real parameter to the formal parameter for the current instantiation of the function. Now, there are two ways in which we find programming languages binding real parameters to formal parameters. First is known as positional parameters. And the second is known as keyword parameters. And what exactly is that? So positional parameters is what we already know, and from many, many languages, and what we see in mathematics, which pretty much says that the first real parameter gets binded to the first formal parameter, and the second real parameter gets binded to the second real parameter. So we have a function, for example, f of xy, and equals to whatever, and we call it with a 3 and a 4, everybody knows that the 3 goes into the X and the 4 goes into the Y. That's what's known as positional parameters. And that's what actually happens in a lot of programming languages. So if we look, let's say, at a function pow, let's rewrite the function pow. We have a float and we have a pow, and it's getting, let's say, a float x and a, let's say, an integer y. There could be anything, right? And what it does is it returns x to the y. Okay, so let's just write it, return x to the y. I don't care about the actual code. And we call this power function with a 3 and a 4. Then positional parameters would say that the 3 goes into the x and the y goes into the 4. That's what's known as positional parameters. Keyword parameters would say, well, you can actually change that if you want. For example, you can call the function using, now this is not C++, but power, and then just write something like y equals 4 and x equals 3. Notice, or some other syntax that's doing the same thing. Notice that there is no, the order here, it does not matter. And what this would do is it would bind the 4 to the y and the 3 to the x. So this is what's known as keyword parameters. And there are languages, a lot of today's standard languages, 5th generation languages actually allow you to do this. You can say, I want this to equal that, to go into this, and this to go into that, okay? And that's what's known as keyword parameters. Now, there are advantages and disadvantages to both, obviously, and let's talk about them a bit. So positional parameters actually just require you to deal with position, meaning to say that I have to, suppose if I have a function that has, 15, 20 parameters, I got to figure out, and I want to give it parameter 1, 2, and 15, I have to figure out how to give the rest of the 14 parameters anyway, because you cannot say the 15th parameter without specifying the first 14. So you might have languages that require you to actually input data. You might have languages that allow you to just put commas. For example, a message box, right? The function message box. So it has all these, but you can put commas and say, I want to enter this one, and I want to enter that one, and in Visual Basic .NET or in other languages. So that, but you have to deal with the actual, all these parameters. But all these guys down here, in a sense, I would have been happy not to give them. Just say this and that would be the end of that. But you can't do that. You have to go and say, okay, the first one is it should be with the default. The second one should be the default. The third one should be the default. On the fifth one, that's the one I want to give. So you actually have to deal with all the parameters, every single one of them. Now there are tricks, like for example, default parameters. But if we think about default parameters, let's say in C++, there's a rule that says the default parameters must be at the end of the list. And you cannot omit one and then include the next. Now, the reason for that rule is very simple. The reason is because since we're dealing with positional parameters, how can I omit the second parameter and enter the third? Because the compiler has no way of knowing that that is the third parameter. It could have been the second parameter. So you have to somehow tell the compiler this is the third parameter, either by actually entering the second parameter or by having a comma-separated list. I mean, in C++ this wouldn't work, but in other languages it would work, having comma-separated list. But you actually have to tell the parameter this is the third parameter. And therefore we get this rule, programming rule, that everybody in their freshman year tries to remember all these rules. If you understand how they work, there's no rules to remember. We actually get the rule that says, oh, default values must be at the end of the list. And once you omit one, you must omit the rest. Now, this obviously is a function of the fact that we're using positional parameters. The advantage for positional parameters is that you do not have to know the formal parameters of variables. Notice that here on the right side, I have to know that these are the names of the formal variables. If these formal variables are in a sense supposed to be hidden from me because I couldn't care less what they are, right? So how can I go and actually use them in code? Now, suppose I go and I changed my function and I changed the name from Y to W. Notice that code outside the local scope might break. So using keyword parameters might be easier for you to write, but it actually has a very big deficiency, that it influences code outside local scope, which is something which is not good, right? You in a sense, you are tying your external code that uses this abstraction of this piece of code to the actual form parameters of the code, which is something which we don't expect and don't want. While we're using positional parameters, this doesn't happen because nobody cares what you call your variables. Call them what you want. I couldn't care less. It's their position that counts. So when you talk about the advantages and disadvantages of formal versus keyword parameters, and actually languages out there allow you to do both. Languages like Python or Ada or other languages say, okay, you can start using positional parameters, and at some point you can switch to keyword parameters. And if you do that, well, there's only one rule you have to follow. The rule is that once you switch to keyword parameters, you can't go back to positional. And the reason that is actually very simple, like everybody can just, deduce on their own. And so all these rules actually just follow through from the way that things are actually implemented behind the scenes.